Remember the first time you saw solving and you freaked out until I gave you the 4 steps and you've been following these 4 steps all along now? Same thing goes with this. There's no difference. The only thing is you're still going to follow the 4 steps, but because this is a multiple angle, you have to do 2 extra things. One at the beginning and one at the end. Okay, so what's the first one? Yup, mess with the domain. That is 2x. So look what happens to the domain. This guy gets multiplied by 2. Well, that's still 0. This guy gets multiplied by 2. That is now 4 pi. Sweet. Okay, so we're good to go. What do we do now? Now we do the 4 steps, right? Think about this. Where is tangent positive? Tangent is positive as add sugar to coffee. Tangent is positive here, and tangent is positive there. Yay. Now, do the absolute value so that you can find the reference angle. All right, where is tangent equal to root 3, I should say? I don't know. I can't remember. Surprisingly enough, it's this guy. It's the thin guy right here. Surprisingly enough, at pi over 3. If you can't remember, just put the coordinates down and remember what tangent is. The coordinates for this are 1/2 root 3 over 2. Remember what tangent is. Tan is sine over cos. So here we go. Take the sine, root 3 over 2. You're going to divide it by the cos, which is 1/2. And remember, this means root 3 over 2 times the reciprocal, and look at that. That cancels out to give you root 3. So in fact, it's confirmed. It's at pi over 3. So your reference here is pi over 3, and over here is pi over 3. Get it? Yes, of course it is. Now, so what does this mean? This means you have 2 angles at present. You have pi over 3 is one of the angles, okay? And the next angle, of course, is going to be way out here, which is going to be at 4 pi over 3, right? Of course, 4 pi over 3. There's your 2 beautiful angles. But remember, though, this is for what? 2 rotations. So it means that you have to go around not just once like what we just did, but you have to go around a second time. Okay, since we're going around the unit circle, this guy's period right now does not matter. You're still going around a unit circle, which means you're spinning this around a whole 2 pi's. So what is 2 pi as a denominator of 3? Okay, well, that's simple enough. That's going to give us 6 pi over 3. So basically, all you have to do is add 6 pi over 3 to these 2 guys, and here's the first rotation. There's the second rotation, right? Coterminal angles, right? Okay, so 6 pi over 3 plus pi over 3, your next one is going to be at 7 pi over 3. Your next one added to this guy is going to be at 10 pi over 3. So what do I do, though? Hey, wait. Remember, this was a 2. So basically, you're going to have to divide everything by 2. So your x values then are going to be pi over 6. Oh, look at this. This is going to be, oh, divide this by 2. Watch what happens. Same like multiplying by half. This is 4 pi over 3 times a half. Look at that. 2 goes into 4 twice, giving you 2 pi over 3. Can you do anything to this one? Yep, multiply by half, still 7 pi over 6. But how about this one? 10 pi over 3 multiplied by a half. Yeah, I get 5 pi over 3. And guess what? There's your answers. Okay, but you're still probably bothered by the fact that this was 10. Well, yeah, so you have a right to be bothered that that's 10. Look what happens when we're talking about the general formula. The general formula is based on the first rotation, pi over 6, and 2 pi over 3. There's your first rotation. Those are your values for the first rotation. Now, let's think about this for a second, okay? What is the period? Because you know and I know we have to add the period times n. Add the period times n. Check this out. What is the period of this? Well, if you go back way over here and you notice that this was tan 2x. Okay, easy peasy. Check this out. You know and I know that the b value is 2. So the period of tan is pi over the b value. Aha, there's the period. So guess what? You're going to have to add pi over 2 times n, pi over 2 times n, where n is an element of I. But wait, this looks kind of strange, doesn't it? I want to show you something which is really, really cool. If you add pi over 2 to this pi over 6, okay? So again, pi over 6, we're going to add pi over 2 to this. Common denominator, right? So I'm going to multiply that by 3 and multiply that by 3. This is going to give me, check this out, this is going to give me 4 pi over 6, which is 2 pi over 3. Well, wait a second. Isn't that our second value? So my point to this is this. If you're adding multiples of pi over 2 to this one, you've already got the answer. You already got the answer for the next one. So actually writing this out is redundant, right? There is your general solution for this equation. Isn't that pretty? And it's following the steps I've always laid out for you.